Hello everyone. Today we'll learn about t distribution, and this t distribution is a probability distribution, of course, and this is used to estimate the population parameters when the sample size is small or when the population variance is unknown. Okay, so here the terms, coming to the terms, we use degrees of freedom. It is nothing but it is the number of values in a set which may be assigned arbitrarily. So here if we have 10 samples, then degrees of freedom, that v, that is if n is 10, v is n minus 1. Okay, so if n is 10, v is n minus 1. So this v is called degrees of freedom. And coming to the formula, the student t test for sample mean is t is equal to x bar minus mu by s into root n. So here we'll take the modulus value. So when we take the modulus value, everything is going to be positive, and it is same thing. So same as the previous ones, if this modulus value of t is greater than this t distribution value, of course you will get a tabular column, or they will give the values in the question itself. So if mod t is greater than t of 0.05, the difference between x bar and mu is said to be significant. So we reject the hypothesis, same as that. If mod t is greater than 0.01, we said the difference is significant at 1% level of significance. So if it is less than the critical value, then we say that the data is said to be consistent with the hypothesis. That is, the mu is the mean of the population. So same as the previous ones, and we'll see problems based on that. And one more thing, the confidence limits we have seen, right? So same way here also, confidence limit for the population mean mu is, actually this modulus value should be less than or equal to t of 0.05. So if we remove the modulus and simplify this, we will get x bar minus s by root n into this t distribution value, t of 0.05 less than or equal to mu less than or equal to x bar plus s by root n into t of 0.05. So when you see 0.05, it is for 95% confidence limit, correct? So in the same way, for 99%, we will write x bar plus or minus s by root n t of 0.01. Okay, so here one minus and plus, that's it. So plus or minus s by root n 0.05 we will write for 95%, and here t of 0.01 we will write for 99% confidence limit. So now we will see some problems. Yeah, 10 individuals are chosen at random from a population, and their heights in inches are found to be. They have given the heights. If you see the sample size, population size, what is that? 10 individuals. So n is very small, of course. So for t distribution, the n is going to be small hereafter. Okay. So they have given the heights in inches, 63, 63, 66, 67, like that. 10 values they have given. Test the hypothesis that the mean height of the universe is 66 inches. Okay, so what is the hypothesis? Mean mu is equal to 66. So we can write the hypothesis is mean mu is equal to 66, and n is equal to 10. So as I told you, what is the degree of freedom? If n is 10, the degree of freedom v is equal to n minus 1, so that's equal to 9. So when you are seeing the values in the tabular column, you should see for the degree of freedom 9. I'll show you the tabular column later. So most of the cases, as I told you, they will give it in the problem itself. So I have written the null hypothesis. Null hypothesis h naught is equal to mean height of the universe is 66. So what is the alternate hypothesis? The mean height is not 66. That is the alternate hypothesis. So first we have to find the mean of these values, whatever the 10 values they have given, no, x bar. So x bar is equal to summation of all x values by n. So whatever they have given in the question, that is these values, say 63 plus 63 plus 66 plus 67, we'll add all the values divided by total number of values will give the mean. So we got this 67.8. This is over. So when I gave the formula, directly I gave you T is equal to x bar minus mu by S into root n, correct? So we have to find this S. In some questions they will give. So here we have to find S. What is the formula for S? The standard deviation only they will give like this. S square is equal to 1 by n minus 1 into summation of x minus x bar the whole square. So 1 by n minus 1, that is 10 minus 1. So 1 by 9 into, what is the first value they have given in the question? 63, correct? There's so many values they have given, no? So 63 minus, what is x bar now? Just now we got 67.8 the whole square, plus next value also 63 in the question. 63 minus 67.8 the whole square, like that. This is the last value, 71 minus 67.8 the whole square. So from each value we will subtract the mean divided by n minus 1. So we got s square, but what we want? S. So we will take the square root. So when we take the square root, we are getting this value 3.011. So if it's more than 4 digits, you just truncate the last digit and write down like that. Okay. Now we are ready to use the formula. What is the formula? T is equal to x bar minus mu by S into root n. So x bar is the average of all the values. Okay. So 67.8 minus mu is what? They have told that in the hypothesis, right? Test the hypothesis that, I'll show the question. Yes. Test the hypothesis that the mean height of the universe is 66 inches. So that is your mean mu. Okay. So try to understand the difference between this x bar and mu. So x bar is what we are getting from the data and this is from the hypothesis. So 67.8 minus 66 divided by S, just now we got S, into root n. Root n is 10. Root 10. So by simplifying this, we got 1.89. I told you have to compare it with the degrees of freedom that they have given in this question. If you see, T of 0.05. So they have given at what significance level we have to check, is equal to 2.262 for 9 degrees of freedom. This value will change according to the degrees of freedom. So for 9 degrees of freedom, this is the value. So in the question itself, they have given you. So you have to compare 1.89 with the given value. So 1.89 is less than 2.262. Thus the hypothesis is accepted at 5% level of significance. That's it. Okay. So I repeat what we have done in the question. Some 10 values are given. Take the mean of the 10 values. Then you have to find S square. S square is 1 by n minus 1 summation of x minus x bar the whole square. This x will change. All the 10 values you will write like that. First value 63, second value 63, third value 66. Like that you will write till the last value. You have to be very careful when you are calculating this. If S goes wrong, everything will go wrong. So once you got S square, you have to take square root. Then apply it in the formula. Whatever answer you are getting, you are going to check. Okay, if that value is less than, we will accept. Same, accept the hypothesis. So since this value is less than, the hypothesis is accepted at 5% level of significance. There is no one tail or two tail here. Just apply the formula and move on. And in the question itself, it will be clear that they will mention T distribution. And you can see this, right? T of 0.05. It means obviously it's a T distribution. And another way of finding it is when the sample size is very small. One more problem we'll see. And this problem is a repeated VTU question. So listen carefully. There is a small mistake in the question itself. I'll tell you what it is. A certain stimulus administered to each one of 12 patients resulted in the following change in BP. Okay. So the values are 5, 2, 8, minus 1, 3, 0, 6, minus 2, 1, 5, 0, 4. 12 patients. Change in BP they have given. They didn't give the BP values. So for example, the BP is say 130. Then after the stimulus, after giving that, they will check again. So there will be a difference in BP, right? That they will write it. So here BP is increased 5, increased by 2, increased by 8, decreased by minus 1, no change in BP. So whatever values they've given the difference in the BP before and after the stimulus. Okay. Now coming to the hypothesis, can it be concluded that the stimulus will increase the BP? So I told you there is a mistake, right? This, can it be concluded that the stimulus will affect or change the BP? It should be like that, because it is not always increase, right? There is a case of decrease also. So this is a negligible mistake, but when you are writing the hypothesis, you have to be careful. And they have given T of 0.05 for 11 degrees of freedom. I told you, right, 12 values are given, so degrees of freedom is 12 minus 1, so 11. So they have given the value also. So we know that it's a T distribution problem. So I'm fixing the hypothesis that the stimulus will not change BP. Okay, that is going to be our null hypothesis. So as usual, we are finding x bar, summation of all values divided by total number of values. What are those values? 5 plus 2 plus 8 plus minus 1 plus 3 plus 0 plus 6 plus minus 2 plus 1 plus 5 plus 0 plus 4. How many values we told? 12. So divided by 12. So it's a normal mean. And when you get more than 4 digits and all, you just truncate it properly. So 2.58, after 8 we are having 3. If this value is less than 5, I'll write 2.58 as it is. Okay. So you are done with truncation. Now what next? We have to find s, then only we can substitute. Same as the previous problem. So s square is equal to 1 by n minus 1 to summation of x minus x bar the whole square. So 1 by n minus 1, that is 12 minus 1 is 11. So x minus x bar, what is the first value? 5 minus this value, 2.58 the whole square, plus 2 minus 2.58 the whole square, plus 8 minus 2.58 the whole square, plus minus 1 minus 2.58 the whole square. When both are minus, what you will do? We will add here. This is opposite sign, so we will subtract. And when you square it, all the values will become positive. Correct? That is what important in standard deviation. So when you write this fourth value, what you will write? Minus 1 minus 2.58. So when you add it, minus 3.58 the whole square. So be careful in the calculation. So like that we will get s square. Once you got s square, we will take the square root and we will get s. Okay, so we are done till s. Now we have to write down the formula for t and we have to conclude the problem. Yes. So what is t? T is x bar minus mu by s into root n. So 2.5833 minus mu we have written 0. Y we have written 0. Divided by 3.088 is yes, root 1. If you remember in the previous problem, they have given mean mu is 66. Because in the hypothesis, test the hypothesis that the mean mu is 66. Here in the hypothesis, did they give any mean? Just think for a second. I'll tell the answer. Because we assume that the stimulus does not affect BP. Correct? So, given is a difference in BP, what they have given. I am saying there is no difference. So, in that case, all the case it will be 0. When I take mean of 0, then what you will get? 0 only. Again, I repeat the question I will show you. This is whatever values they have given is change in BP. Okay. So, here in my hypothesis, I am saying there is no change. If there is no change, all is there, you can see 2 zeros. When there is no change, according to my hypothesis, everything will become 0. So, from the hypothesis only you will take this second mu. So, in this problem I am taking mu as 0. So, 2.5833 minus 0 divided by this answer into root 12. So, you got 2.89. So, when you truncate it 5 and above, one digit will increase. So, 2.9 which is greater than 2.202. So, it is going outside, correct, the distribution. So, what is our conclusion? Can you conclude it? Yeah, I have written the conclusion in short over here. So we reject the hypothesis. Since the value is greater, we reject the hypothesis at 5% significance level, and we conclude that with the 95% confidence that the stimulus in general is accompanied with change in BP. Don't write increase. In the question they have given increase. So even if you write increase also, they won't reduce the marks because the question itself is wrong. And so in this problem, what is something different from the previous one? Mean mu is 0. So how we got mean mu is equal to 0? Because it's from the question. They have mentioned in the hypothesis there is no change. So no change means the difference that what they have given, mean mu is 0. That's it. Another problem. A sample of 10 measurements of the diameter of a sphere gave a mean of 12 centimeter and a standard deviation 0.15. Find the 95% confidence limits for the actual diameter. What they have given, the moment confidence limit also, if there is another name. So, but when you see the word limits, then you can guess it. So, which formula you have to use? So, n is equal to 10, x bar is 12, s is 0.5. What is the formula I told? X bar plus or minus s by root n. Since they have given 95%, I will write t of 0.05. In the question, if they ask 99%, then I will write t of 0.01. Okay. So, x bar is nothing but 12 plus or minus s they have given 0.15 divided by root 10 into this t distribution value they will give here, or you have to take it from the tabular column. I will give you the tabular column, same as normal distribution. So, you will get a tabular column, easy for you to check. You have to check the degrees of freedom and then you will find it. So, 2.262. So, 12 plus or minus this value. So, one positive value, one negative value. When you are simplifying, you will get 11.893 centimeter to 12.107 centimeter. Please use the units, whatever they have given in the question. In this question, they have given centimeter, so you are using the centimeter. So, this is the confidence limit for the actual diameter. Most of the t distribution problems will be using the direct formula. Very few problems along with that they will ask you to find the confidence limit. In that case, this is the formula. Only two formulas are there. For t, confidence limit. Of course, to find s, we have another formula. Now, another question. A large group of boys and girls were given test. We hate the word test, right? Okay. The mean score and the numbers in each group is given us. They have given a tabular column. One second. Yeah, this is the tabular column. They have given mean 74, 70. This is boys column and this is girls one. So standard deviation is 8 for boys, 10 for girls. N is 12 sample they have taken for boys and 10 samples they have taken for girls. Sometimes this value will change. So it is not mandatory when you are writing or comparing two different samples, then it is not mandatory that it should be equal in number. It can slightly vary. Okay. So coming back to the question, this is a slightly different problem from the normal t distribution ones because we are having 2 mean, 2 standard deviation, 2n. Okay. Is there a difference between the means of two groups significant at 5% level of significance, and they have given the tabular column value t of 0.05, 2.086 for 20 degrees of freedom. Now I have a question. How you got degrees of freedom as 20? Can you think for a second? Here, for boys, the total number is 12. So, degrees of freedom 12 minus 1, 11. Here for girls, total number is 10. Here degrees of freedom 10 minus 1, 9. So, here 11, here 9. 11 plus 9, 20. In case if this value is not given, you have to check it from the tabular column. I told you, right, degrees of freedom. So, for boys minus 1 plus girls minus 1. 12 minus 1 plus 10 minus 1. So, degrees of freedom is 20. If they have given only one n, what we will do? N minus 1. Same way. N minus 1 here, n minus 1 here. Add, that is a total degrees of freedom. Okay. And of course, the first one, x bar mean 74. First standard deviation S1 8. N1 12. You have to write like this because this is boys, right? Boys are having a mean 74, standard deviation 8, N1 12. Same way girls, Y bar 70, S2 10, N2 also 10. So we have written the values. Now this is the formula. If there is a difference, x bar minus y bar divided by s into root of 1 by n1 plus 1 by n2. You remember that difference in mean, we will subtract it. Here sigma 1 square plus sigma 2 square we will write. Correct? So here we will write s outside root of 1 by n1 plus 1 by n2. And this is s square. How to find s? This is the formula. Okay. To find s, we will use n1 s1 square plus n2 s2 square by n1 plus n2 minus 2. In the previous one, difference of means, 2 standard deviation we will write inside. Here only one s, and how we are finding s? By using this formula. So for t, this is the formula. We have to find s first as usual and then substitute there. What is s square? n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. Why we have written minus 2? Because n1 minus 1 plus n2 minus 1. 2 times the degrees of freedom we will subtract, right? So we have got minus 2 here. So just substitute the value. N1 is 12, S1 square 8 square 64 plus N2 is 10 and S2 square, that is 10 square 100 divided by 20. So we got the value 88.4. So we have S square and of course we want S. Take the square root, so we are getting 9.4. Now you have to substitute in the formula. Yeah, if you see, this value 0.994 is less than what is given in the question. In the question, this t value they have given in the question, 2.086. So 0.994 is less than 2.086. So we accept the hypothesis. Actually, we won't say accept, we will say we will not reject the hypothesis. So thus the hypothesis that there is a difference between the mean of the group is accepted at 5% level of significance. So here if you remember, we started this problem without writing the hypothesis. So here you can relax a little bit. Of course you have to write the hypothesis, but you can relax because there is no one tail or two tail test here. So what is the hypothesis? Because your question is there a difference between mean? So I will write that there is a difference. So how to write the hypothesis? Same. Is there a difference means between the means of two groups? Then they will say there is a difference between means of two group, and then we will continue the problem. Okay. So this problem is slightly different. 2 mean, 2 standard deviation, 2n is given. Then what is the formula for t distribution? Each problem is different. The first one we saw as a normal one. Second one, slight variation where we have taken mean mu as 0. Then the third one we saw with the limits, confidence limits. And the fourth one is a problem with 2 mean and 2 standard deviation. So here comes the last problem. And again, if I teach you 5 problems, all the problems will be of different type. Okay. So this is the last type that you have to see. If you know these 5 problems, you can attempt any problem in t distribution. A group of 10 boys fed on a diet A and another group of 8 boys fed on a different diet B for a period of 6 months. Recorded the following increase in weight. Okay, poor boys. Now we'll see. This is diet A. Okay. Here if you notice here, this is for 10 boys they have given and this is for 8 boys. No harm. Okay. As I told you earlier, need not be same. This is the weight of the boys, 10 boys who are taking diet A. This is the weight of 8 boys who are taking diet B. So this is given in the question. Now, test whether the diet A and B differ significantly regarding their effect on increase in weight. So this is the hypothesis. They have given the hypothesis, just we have to test. Now, we have to find x bar, add all the x values, okay, divided by 10 because we have 10 values here. 5 plus 6 plus 8 plus 1 plus 12 plus 4 plus 3 plus 9 plus 6 plus 10 divided by 10. So we get 6.4, and similarly we are going to find y bar. Y bar, how many values are there? 8 values. So 2 plus 3 plus 6 plus 8 plus 10 plus 1 plus 2 plus 8 divided by 8. So y bar we got 5. Okay. So now this is a new formula. Of course, the t, if you remember the t, the final t formula is the same. T is equal to x bar minus y bar by s into root of 1 by n1 plus 1 by n2. Be happy for that. This formula is same. And s square also same. 1 by n1 plus n2 minus 2 into summation of x minus x bar the whole square plus summation of y minus y bar the whole square, because we are having two different sets. Correct? So 1 by n1 plus n2 minus 2. n1 is 10 boys, right, in the first one, and n2 is 8. 10 plus 8 minus 2, okay, into summation of x minus x bar. So each x value we will write like the same as the first problem. We will square the difference, and then same y minus y bar the whole square. We'll do it here, and then we'll simplify this. Now coming to the simplification. Yeah. So n1 plus n2 minus 2 is 10 plus 8 minus 2, 18 minus 2. So 1 by 16. This you have to simplify. Okay. X minus x bar the whole square, how we will find it? I have already told you. The value of x, first row value, 5 minus x bar value is 6.4 the whole square, plus 6 minus 6.4 the whole square, plus, like that you will write all the values, each and every value. What is the last value? 10 minus x bar is 6.4 the whole square, plus what are the y values they have given? I am talking about these. So these are the y values. So what I will write for the second one? 2 minus y bar is 5, 5 the whole square, plus 3 minus 5 the whole square, plus 6 minus 5 the whole square, plus 8 minus 5 the whole square, plus 10 minus 5 the whole square, plus 1 minus 5 the whole square, plus 2 minus 5 the whole square, plus 8 minus 5 the whole square. What I told you is only summation of this. Similarly, you have to find this and then add it. So you will get this finally as 11.525. So we got s square. What we want for the formula? We want s. So take the square root. So if you take the square root, you will get s as 3.395. Finally substitute in the formula. X bar minus y bar divided by s into root of 1 by n1 plus 1 by n2. So when you are getting, when you are simplifying, you are getting 0.87. Okay. Now what could be the conclusion if you get this? This tabular column value, we will check it, right? So we need tabular column value. And the degrees of freedom is what? 16. So in the tabular column, you will check 16. I don't have the t distribution table right now in the book, otherwise I would have shown you. So now I will give you the t values directly. Yeah. So this t distribution value for 16 degrees of freedom is 2.12. I took it from the tables. So what we got is 0.87. So 0.87 is less than the table value with the 16 degrees of freedom at 5% level of significance. Hence we conclude that the two diets do not differ significantly regarding their effect on increase in weight. Okay. So that's it. These are the problems in t distribution. We can finish t distribution in one class. If we practice these 5 problems, more than enough. All the other problems will be similar to it. So in the next class, we'll see about chi-square distribution. Thank you.